Hello everyone! Let's talk about prompt engineering. What is it? Is it an art or a science or essential skill for building generative AI solutions, or maybe it's your next job title? I hope that by the end of this session you will give an answer for yourself. My name is Maxim Salnikov, and I work in Microsoft in Norway, where I'm based. I'm big fan of the developer communities. I organize few meetups and conferences myself, and I often present at both in-person and digital events. And yeah, I'm in the development for many years. So basically, I started to build some web applications, web pages by those times in late 90s of the last century. And in Microsoft, my job title is complex, but in simple words, I'm helping developers to succeed with cloud and AI technologies. That's about myself. Let's talk about generative AI solutions first, very briefly, just to set the stage. And I really love this diagram from a recent IDC report, and it clearly shows that what we call generative foundation model is a centerpiece of pretty much all workflow. It's the core of technology, and based on that you build all next layers to have proper business impact and to offer this or that sample use case. Like what kind of possibilities do we have with generative AI? First of all, there are tons of them. Just to name a few from this diagram, you can build your very own product knowledge management system, or it might be exposed as a chatbot. Or you can use power of generative AI models for code generation and code documentation and writing tests. Lots of opportunities for your sales departments, infinite opportunities for automating of day-to-day job of your marketing departments, HR. Like I believe almost all departments in a regular company can benefit out of using and maybe building first this kind of solution. But yeah, it all starts with the model. And these days you don't need to build this model from scratch. So like build model, then train this, then deploy this, then manage it. No. And after all, the main kind of model that we highlight in this session is large language model, and it's called large for a reason. To actually get this model ready for some interesting scenarios, you have to invest a lot efforts, time, knowledge, skills, and only then you'll get some satisfactory results. But as I mentioned, in many cases you don't need to do it on behalf of your own company or as an individual developer, because there are many companies that did this job for you. So they expose set of different models exposed via API endpoints. So you just use this. And yeah, this is how, for example, ChatGPT, this customer service facing, is working. I mean, this is like a customer facing application, but under the hood, it's backend using respective underlying large language models. And on this slide, I picked only few of the models available on the market and specifically highlighted ones built by large companies. And all these models are very different. in many senses. First of all, by the size, by quality of content they generate, by the way you communicate with these models, like either text to text or text to image. Some models support multimodality when you in one request supply both image and text. In other dimension, some of the models are general enough, like ChatGPT, it's about like texts in general. Some of the models are super highly specialized, for example, something for helping you with biomolecular research, like many different models, very different ways to work with them and different results. But there is one common thing. And on this slide, I picked a few examples from maybe the most popular services and respective models. How do we ask Midjourney to generate image to us? So we go to Discord bot and write textual description of the image we want to get. Okay, noted. Next example is Microsoft 365 Copilot. To get smart draft of our document, and by saying smart, I mean really smart. For example, based on your previous meeting notes that were transcribed and summarized. So it like said, whole family of copilots are working for you there. But again, you start with writing a comment like draft proposal from yesterday's meeting. Okay. Next example, this is GitHub Copilot Chat. And yeah, GitHub Copilot has multiple modes of working, and maybe the most popular and well-known one is just this inline code suggestions, but I encourage you all to try its chat capabilities and possibilities. This is super interesting. This is where you literally talk with your code, like where you can ask Copilot to write tests to check what could go wrong in this particular function, or chat with Copilot about naming conventions in this particular file. Very interesting. And again, it's chat, and you type in some text. And in the bottom of the screen, last but not least, super well-known, super famous, I'd say, ChatGPT. And here, by saying ChatGPT, I mean customer-facing service, not respective model that is powering this service. Definitely, this is chat, right? So you can either order something very directly, or just type something and ChatGPT will continue this sentence or paragraph or whatever for you. This is how it works under the hood. One common thing, we start with the prompt, and in many cases we continue with prompt. And this is where prompt engineering comes to the play. Of course, maybe you cannot call yourself prompt engineer after a few conversations with ChatGPT, but at the same time, I'm pretty sure that during these few conversations, few dialogues, you started to notice some patterns, like what works better when you communicate with ChatGPT, right? Either like more explicit instructions or something mentioned implicitly. Yeah, so you maybe unintentionally start being prompt engineer. But again, to think about prompt engineering like about profession, like about discipline, of course we have to take a bit more serious approach, and yeah, basically this is session exactly about that. There are lots of definitions of prompt engineering available, and I picked and like compiled few parts from multiple sources to create what you see on the screen now. So for me, this is process of designing, in some cases we just start from scratch, right? Refining, and in 100% of the cases this is iterative process. I promise you that your first prompt will not be optimal, will not be efficient enough. And optimizing, so maybe we can go back to existing solutions, existing prompts, and fine-tune them even more to make them even more efficient. So designing, refining, optimizing input prompts to guide model toward producing more accurate outputs, or like outputs we expect, or satisfactory outputs, with one important point, while keeping cost efficiency. And yeah, not a secret that in many cases, like if you talk about some serious applications at scale, you have to pay to these third-party providers of models and respective APIs for actually getting this functionality, right? I mean, this is the case when we don't want to spend efforts, investments, resources for building our own models, building and maintaining. In many cases, it's way more optimal, let's say, to rely on these third-party services like OpenAI itself, like Azure OpenAI, and a bunch of other providers, depending on what kind of model, what kind of functionality do you need. Okay, so how do we write efficient prompts? Well, stay tuned. We are going through some methods, best practices, and other interesting topics related to prompt engineering. But let's start with what is prompt, or prompt anatomy, if you wish. On this, in this example, that is a bit synthetic, maybe not 100% realistic, I gathered, and this is actually why it's not realistic, I gathered as many components as possible. I mean, of course we can split even further, but these are core components that many prompts include. Not all of them, but quite let's say few of them. And the main one is instruction itself, like in this sample. Write a product launch email for new headphones. In this particular case, it's very straightforward, very explicitly expressed, right? And sometimes the instruction is not that visible, not that obvious. Again, back to the discussion, how large language models work. They just kind of continue your sentence, continue your prompt, and in many cases you don't even need to have such a straightforward instruction. But yeah, maybe for better efficiency, be quite straightforward, explicit, if not simple here. Then some input data, or primary data, if you wish, also very important component, and I believe a vast majority of the prompts have this. In our cases, we explain what are the features of this product, so large language model can let's say double click or elaborate on these features in its digital brain. So this product is AI powered, and also we provide concrete price. Okay, next component, optional, but in many cases it's highly desired, again in the name of prompt efficiency, is context or secondary data. This is where we can describe maybe kind of sentiment or tonality of expected output. In our case, we ask to be friendly and exciting, like all marketing emails about product launch. Then we are very concrete in explaining target format we expect to get back. And as you can imagine, if we ask for JSON, most likely this concrete API call will be not the final one in the chain of API calls in our backend for this functionality. So most likely we take this JSON and pass it to the next node of our solution. Okay, also we can provide examples, again, to get better results, get like more satisfactory results. And in this concrete scenario, a bit actually unintentionally from my side, it plays two roles, this example. So we double down on explanation of the format. So in our example, we repeat one more time that it's JSON and these are the fields. And by the way, of course, in that case, a really good idea to be consistent, right? If you mentioned fields like with the names like this in output as JSON, blah, 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 don't forget to use the same fields in example, just not to confuse large language model. And in addition to the format, we also provide some examples of subject and the body. And maybe our marketeers wrote these examples again to somehow guide the model. And in that case, I believe it also supports well context part of the prompt. Again, to make it more efficient. And last component you see on the screen now is definitely optional, but again, this is helper for model to understand that yes, we expect output, right? And of course, like it will come to us anyway, right? But in some cases, it's all based on experimentation. This concrete Q can also improve the prompt. This is how we, people or humans, see prompts. This is how computers see prompts or large language models, if we are a bit more precise. Before any further processing, it splits prompt into tokens. Disclaimer here. This concrete approach might not be applicable for 100% of large language models available on the market, but here we talk about mainstream ones, and at least for GPT family, ChatGPT family, and other models created by OpenAI and deployed by OpenAI and Azure OpenAI, this is the case. And I assume majority of large language models work the same way. So what is token? First of all, this is not a session about data science, and tokens is from that field. I'm not going to deep dive into how large language model exactly understands our intention and generates word. No, let's be more technical here. One token we could approximately map to 4 characters if we talk about English language. Or like to generalize, 100 tokens is approximately 75 words. And you see that some words are tokens like themselves. I mean, one word plus preceding white space is one token. Some words split into multiple tokens, for example, headphones, and how it happens exactly, it's on LLM side. Again, we don't go into this rabbit hole of explanation. Why is this concept important, and why should you ever care about what's going on other side of your API call? Because this is how you pay for using these models, and also it applies some extra limitations when you use these APIs. Again, so here we go back to scenario when you use third-party providers for these models and respective APIs, and I assume again this is mainstream in generative AI scenarios. Only like few companies can afford and have the need to build their own models that they kind of use for free. Of course, under the hood, it's absolutely not for free. Like training and maintaining model is very expensive. Again, it's way more profitable to rely on third-party services in that context. Yeah, so again, this is a particular example for Azure OpenAI. So prices and the ways of pricing might be slightly different in this or that scenario, but I believe they are quite close to each other anyway. So you pay for number of tokens you send in your request and numbers of tokens you receive back. And of course, you multiply everything on the number of these API calls you made, both in production and also in during development. Maybe, of course, during development is just tiny fraction of the cost, but yeah, I just wanted to list everything here on that list. And you see that like even again back to case of Azure OpenAI, price for tokens you send and you receive is slightly different, and this is, by the way, in Norwegian krones, and 1 Norwegian krone is approximately 1/10 of dollars. So you see that, like, and this is for 1,000 of tokens. So you see the prices are quite affordable, I'd say. Yeah. So just again, your attention. We are not you are not paying for characters or for words or just for number of API calls. No, you pay like concretely for number of tokens you send and receive. So to estimate cost, you have to somehow estimate number of tokens you send, and on receivable side, you can specify maximum amount of tokens you want to receive from this particular call. So it's also manageable, I'd say. And as you see, prices are also different from model to model, and they give you different results, of course. Model selection strategy is very simple here. You always start with the most advanced one. You fine-tune your prompt to get desired results, and then it's up to you. You might want to downgrade to like cheaper model, and if results are still good, or you manage to fine-tune model to get the same results, yeah, you can stay there and save some extra dollars. And also I mentioned that number of tokens applies some limitations, right? And this is exactly about context column you see on the screen now. Even if you are not going to save dollars and you are good with super long prompts you can send to large language model API, you still cannot do this, because you can send only limited number of tokens per request, and in this table you see examples for some of the models, either like 4,000 or 16,000 or like 8 or 32. That's quite a good number still if we map like these thousands of tokens to respective thousands of words. So this is like, here we talk about pages of texts, right? So I mean, you don't have to worry, do you send prompt consisting of 2 or 20 paragraphs, right? So it still fits this context. But at the same time, yeah, we are not talking here about like full books or larger. So keep this in mind as well. And of course, like the development direction here is models are having larger and larger context window or just context. So sooner or later, yeah, you will be able to send really huge corpuses of texts if you need it. Maybe you can find some other way to execute these calls, again thanks to some methods of prompt engineering. And also to finalize on space efficiency and thus cost efficiency, just a few very concrete, very technical points. White spaces, use them carefully. As you see on this illustration, every single white space is taking one one token, right? And the one before the word is actually combined with the word. And by the way, here and all previous slides, the color means nothing. This is just to illustrate how we split into tokens. I mean, there are no green tokens or yellow tokens or whatever. Just ignore the colors. It's just for better visualization. Next point, sometimes token can be counterintuitive. I mean, we could imagine like that the shorter word or the shorter expression is fewer tokens, but in reality not. And example with the dates is illustrating this very, very good. So if we look how we can provide concrete date, October 18th to the model, if it's part of our prompt, a few options, right? And the most token efficient one is second from top, right? You see only 3 tokens, and it's not the shortest one, right? And the second one from bottom, I believe, is the most expensive one. Even it's in number of characters, it's shorter than the one that contains only 3 tokens. It's containing 1, 2, 3, 4, 5, 6 tokens. So it's double more expensive, right? So keep this in mind. And of course, there are lots of tokenizers available, both in multiple languages, including the ones that work just in the browser. So before sending prompt, you can estimate how many tokens and how you can optimize this. And also, if you want to send some table-like data as a part of your prompt, don't be shy. Use tabular data. Use some separators like tabs or pipes instead of trying to give field name to every value. So don't try to recreate JSON format. Just supply it as table, and it will work fine in vast majority of the cases. Okay, now let's list few technical recommendations. First of all, I already mentioned this in the beginning when we looked at prompt anatomy. Be very specific, both in your order, in the order part of the prompt and all other components. So leave as little to interpretation as possible, and you are trying to restrict the operational space of the model. Then you remember that there are many components of the prompt, and in many cases you don't even think about this part of your prompt as a particular component, but still try to split in at least in your mind, because order of these components matter. And again, this is always about experimentation. Try to change the order, for example, like primary data, secondary data, or format, or something else. Few experiments and you will see, okay, these are better results or these are better results. There are no very concrete, very straightforward rules, except only a few ones, and I will tell about them a bit later. So experiment. Just randomize these prompt components and see what happens. Double down. Sometimes to get even better results, you need to repeat the instruction, for example. So you might want it at the very top of the prompt and maybe as a last statement again. Maybe even somehow rephrased. Again, this is just a question of experimentation. And yes, of course, if you have some repetitions in your prompt, this makes your prompt longer. This makes number of tokens larger, and thus you pay a bit more, right? But I believe you are focused on satisfactory results, right? On best achievable results rather than on saving few cents per 1,000 prompts. So again, experiment, and sometimes longer prompt works better. And last in this point, it's specifically for the cases when you ask large language model to categorize or to classify some text, and if, for example, you provide some categories, or let's call them buckets, it's a really good idea to give the model an out, to very explicitly state in the prompt about if you are unsure which category to use for this entity or item or whatever, just say like I don't know, or like I don't know where to put it. It's like up to you what exactly to answer, instead of putting this item into some category anyway, right? In many cases, it's still like some human review needed, right? All these results of classification and categorization, and it's simpler for you to, let's say, categorize uncategorized items rather than trying to surf through what's where in every bucket and understand is it incorrect category or not. Yeah, so this is also a good recommendation. Few more technical recommendations based on the ones we just listed. So about order and about doubling down, I want to double down again. Start with clear instructions. So maybe this is the only like very straightforward rule in the ordering of your components. And you might also need or want repeat instructions at the end. I mean, if your prompt is giving good results without this repetition, that's fine, so you save some dollars. If you are not very happy, try, maybe this can help. Don't be shy with adding very clear syntax. If you want to be even more explicit in separating these prompt components, for example, to let model exactly know that this is example and this is example number 1, number 2, this is desired format, just use some separators. So I see the most popular ones, for example, set of hash symbols, I mean 3, 4, 2, there is no any kind of rule, hashes is enough to somehow separate these components, or maybe set of the dashes, and give headers to these components. Also experiment. I will repeat this word many times during this session. Sometimes you need to simplify your instruction, and if you feel that this instruction contains actually multiple like sub instructions, in some cases it might be better option to send 2 requests instead of 1. Again, it might be a bit more expensive in number of tokens you send, but again, most likely you are focused on getting the best out of large language model. So break the task down is recommendation. And last one in this list is about supplying and adjusting extra parameters. This is relevant specifically for OpenAI APIs and respective Azure OpenAI Service APIs. I assume that other providers have something similar, maybe with different names, not temperature and top probabilities like in this case. But long story short, in addition to the prompt, like to main payload of your request to this API endpoint, you can also provide set of parameters as a parameters of the request, and temperature and top probabilities are 2 main ones that kind of control level of creativity of the large language model. And rule of thumb here is following: if you are about some like full creativity mode and you ask large language model to generate something for you, put this to the maximum. If it's more formal thing like categorization or classification, try to limit creativity and maybe like move these parameters, this kind of sliders, if you use it in Studio, closer to 0, or set it as a text when if you send the API call. Okay. Time for some examples and for illustrating couple of methodologies. And we start with the discussion about zero-shot versus few-shot prompts. Very simple. In what we call zero-shot prompts, you provide zero of examples. And yeah, this is like all about examples. If you provide 0 or 1 or few. Also, in some sources you will see that few shot method also split into one shot or few shot. But for simplicity, let's just call this either 0 or few shot. In this example you see on the screen, this is insurance company that is building kind of first line support service for categorization of customer questions or requests. Just imagine that you had a phone conversation and then using some AI tool you transcribed everything, maybe summarized, and now it's time to direct it to this or that department. And this is actually where generative AI can help. This is one of super straightforward capabilities of generative AI solutions. Yeah, so here we in this prompt we ask to classify. And by the way, this example is also illustrating this give model out approach. If you see, like, choose 3 if the question is not relevant to insurance. So instead of still trying to map these questions to either auto insurance or flood insurance, we better say, no, this is not about insurance, or like, I'm not sure about if this about insurance at all. Good technique. And yeah, then we provide customer question itself. And also another technique from prompt component is Q. So classified topic, like very straightforward way where model will answer, right? And in few-shot, one more component added to help large language model to work even better. And we supplied a couple of examples here. So, like, to be more precise, this is 2 short prompts. In some cases, you don't need to supply examples. I mean, if you're lucky enough to have zero-shot prompting work good for this specific task, perfect. You again save some cents on sending shorter prompts. In some cases, you better provide examples, 1 or 2 or multiple, to achieve good results. Next technique called reasoning, and another name of this technique is chain of thought. This example is a bit synthetic, and maybe you don't want to often use large language models for solving some tasks from mathematics, but still, in some scenarios, this technique is super useful. Long story short, again, I'm not diving too deep into how large language models work under the hood, but they try to find, let's say, the most statistically probable answer, and or in simpler words, like lowest hanging fruit answer that is incorrect in some cases. And the answer here you see on the screen on the left hand side of the screen, in like before section, 8 million liters per year is incorrect. Again, model was really lazy to understand the task and do proper calculation. If in the same prompt we add just one sentence, let's think step by step and explain the calculation step by step, model gives different output, and yeah, as we order it, it gives step-by-step calculations. And what's more important, unfortunately, yeah, it's hidden by video stream, but I can tell you, and trust me, the answer is correct. So just it works like a magic. So you just ask model to think a bit like longer, let's say, like this, and you get not only this chain of thoughts, maybe this is unneeded for you, but what's needed is correct answer. And you can elaborate on that method by providing examples. Like instead of this kind of sentence where we explicitly ask think step by step, we better explain this kind of in action, right? So we in our sample prompt we explain model what we expect from it, and we like mimic this chain of thoughts ourselves. Just another way to achieve similar results. Another very important and very popular technique, maybe it's not about prompting itself, but about the way you architect your backend component that is communicating with API endpoints, is prompt chaining. And in many cases, when you build more or less complex, I mean, not hello world solution based on generative AI capabilities, it's not a question of sending just one prompt and getting this result back immediately. No, you might organize like chain of these calls, and in every next of the call you use completion, you use result of the previous one. Like in this also a bit synthetic example, where we first extract entities from some article about iPhone, then we ask model to summarize information about this product. So maybe in this case we also could send requests to some internal database to find description of this product based on entity extraction on the first step. And then after all, final step, we ask to provide sentiment for these textual descriptions. Like, is it positive or negative or what? So this is illustrating chaining of the prompts, and also illustrating technique split task down or break task down into multiple components. And of course, in this particular scenario, you have to wait for every single call to complete before calling next one, right? In this context, you cannot parallel this. So it's super important to find API provider that that is fast, right? And also, since the number of tokens is affecting also like speed of this API endpoint, of like speed of receiving answer. Also a good idea to keep an eye on length of the prompt you sent. Where you can parallel all the story is another technique called prompt chunking, and you might want to apply this technique if you want to summarize really large amount of text, like whole book that you cannot send as one prompt. What you do, you split this corpus of text into some chunks, you send them one by one, and here you can send them in parallel. And after all this, in every request, you ask to summarize this chunk of text. What you do next, you gather the summaries and summarize the summary in your final call. Another very popular and important technique. Some more concrete examples on last minutes of the session. Using all these techniques, using all these best practices we went through, you can build really smart solutions to work, to let generative AI or large language models work on your own data. So instead of relying on the data that was gathered by this large language model during training, and it's always some like snapshot in the past, you can kind of plug in your own data. And here you can use your favorite database. In this example, you see it's Azure Cognitive Search, but it could be anything, right? Unfortunately, we don't have enough time here to explain this super important technique called Retrieval Augmented Generation, or RAG. But this is, again, you use some prompt chaining, you use some methods that we described before to, for example, generate chat bot that is communicating exclusively on your data. That is not hallucinating, that is not inventing data, that is only answers data using PDFs or markdowns or whatever other documents you provided. To see this in action and to see the code, you can go to this GitHub repo I created based on work of my colleagues in Microsoft, and it's all in JavaScript, both backend, it's Node.js, of course, if you talk about JavaScript, and the frontend is React plus Next.js. You will see how that works, and this is illustration of this retrieval augmented generation I mentioned. In Azure, we actually streamlined this experience using Azure OpenAI service on your data. So you can now achieve same results like in my previous repo without writing any line of code, right? You just go to Azure AI Studio, upload documents, create respective database resources, and then you can just deploy your application to app service on Azure and see how that works. And of course, if you need to customize this, all possibilities are for you. To finalize, I want to introduce few libraries that help you with building like chains of prompts and in general build generative AI solutions that with a great developer experience while we referring this large language model APIs. The libraries are LangChain and Semantic Kernel. They are actually playing on the same field with slightly different approaches and different sets of programming languages and frameworks supported. I ask you explore both of them. You will find lots of interesting ideas there. And also specifically, I want to highlight a product by my colleagues from Microsoft called Prompt Flow. As name says, basically you think about your part of backend working with generative AI as flows of a particular prompt, and then like leaves on this flow is your actually code snippets, but the foundation, that the tree itself is a flow of prompt. Few resources, like 5 links that will keep you busy for at least 1 week if you want to learn more about prompting and yeah, get some practical hands-on knowledge. And I hope that organizers will share this deck so you'll get all the links available. And just a few days ago, we had super successful conference, Prompt Engineering Conference. You don't have to attend this conference because it's completed, but all video materials are available, and it's 10 hours of video sessions about prompts. And my last call to action, let's connect and chat. Find me on LinkedIn. I'm Maxim Salnikov there, and this QR code is to my profile. And let's talk about prompting. So what is prompt engineering for you? Is it art or science, or you're inspired enough to look at it as your next job title? Tell me on LinkedIn. Thank you and bye.